Hello and welcome to The Shy Scientist. I'm glad you've joined me tonight. Before we set our course for the red sands of Mars, tell me, where in the world are you listening from? Whether you're tucked in bed, curled on the sofa, or sitting quietly somewhere, I'm happy you're here. If you enjoy these journeys, a quick like and subscribe means we can keep exploring together. Turn on notifications, and you'll know when our next adventure begins. It's a small gesture for you, but it keeps our little community growing. And to those already aboard, thank you. Make these voyages possible. Tonight, I'll do my best to guide you gently toward rest, though I warn you, Mars might be fascinating enough to keep your mind wide awake. If that happens, at least you'll drift into dreams with a few new cosmic facts. So let's begin. What if one of the quietest places in the solar system is also one of the most mysterious? Mars, our small rust-colored neighbor, has inspired wonder for as long as we've looked to the night sky. Ancient astronomers watched its steady glow, told stories of gods and warriors, and imagined worlds beyond Earth. Yet behind that soft red shimmer lies a place far stranger than it appears. Dawn frost on silent dunes, winds whispering across endless plains, canyons deeper than oceans and mountains that scrape the edge of space. We'll explore how Mars may once have been blue with oceans, how it lost its protective skies, and what it can teach us about our own fragile home. We'll follow the path of rovers and orbiters, machines built to taste the soil, endure the cold, and send back glimpses of a land no human has walked. Mars has always stood out in the heavens, a warm ember among the cold stars. Ancient skywatchers noticed it didn't move like the rest. For months it drifted eastward, then seemed to pause, move backward, and resume, an illusion called retrograde motion. In the days before telescopes, this strange dance made Mars feel alive, purposeful. For centuries, cultures gave it names tied to war and power. The Babylonians called it Nergal. The Greeks and Romans named it after their war gods. Its red glow became a symbol of conflict, even though its deserts are silent. The true reason for its looping path came with the heliocentric model. Earth simply overtakes Mars in its orbit, making it appear to reverse. Much like passing a slower car on the highway, it's all perspective. When Galileo turned his telescope toward it, Mars became more than a wandering point of light. It became a world. Later, Christian Huygens spotted surface markings and estimated a day just over 24 hours, not far from Earth's own. Over time, we mapped its polar caps, guessed at water ice, and dreamed of life. By the late 1800s, some believed they saw canals, straight lines etched by intelligent hands. It was an illusion, but the dream endured. Mars is a constant companion in our night sky, a reminder that the universe is both vast and strangely familiar. So, settle in. Tonight, we drift toward that quiet ember, where every grain of dust tells the story of a world that might have been. Long before we sent rovers or landers, Mars taught us something vital. The universe is in motion. Worlds shift and follow paths that are never as simple as they first seem. Understanding Mars' journey helped us better understand our own place in the cosmos. Around 4 billion years ago, the solar system was a turbulent cloud of gas, dust and ice swirling around a dimmer young sun. Small grains collided, forming planetesimals that grew into rocky worlds. Mars took shape between the Sun and the future asteroid belt, in a region with fewer raw materials than Earth's neighborhood. That shortage left it smaller, half Earth's width, only a tenth of its mass, a size that would shape its destiny. Big planets hold heat longer, powering molten cores and magnetic shields that protect their atmospheres. Mars cooled quickly, its magnetic field fading. Without that shield, solar winds stripped away much of its air, turning what might have been a warm, wet world into the cold desert we see today. Its early surface was anything but quiet. Lava poured from volcanoes, some growing to record sizes. Olympus Mons towers nearly 3 times Everest's height, its bulk the size of France. With no tectonic plates to move hot spots, volcanoes could build for millions of years in the same place. Impacts were common too. One may have carved the Borealis Basin, reshaping an entire hemisphere. These collisions could briefly warm the air, melt ice, and send water racing across the land. Ancient Mars shows clear signs of flowing water, winding valleys, scattered lake beds, and massive outflow channels carved by sudden floods. Some of the best evidence comes from delta formations, like the one in Jezero Crater, where NASA's Perseverance rover now explores. Such sites rich in minerals formed by water, clays, sulfates, may have sheltered life if it ever existed. Over time, as heat faded and the atmosphere thinned, water retreated underground or froze at the poles. Without tectonics to recycle the landscape, Mars preserved much of its ancient surface. Riverbeds billions of years old still lie almost untouched. A geological scrapbook holding the memory of a wetter, more dynamic past. Today, when we study Mars from orbit or the surface, we're reading those preserved pages, the record of volcanoes, impacts, and vanished water that shaped a world both alien and strangely familiar. Minerals on Mars act like chemical signatures, proving that water once interacted with the surface for long periods. Clays hint at early stable conditions, while later, sulfates point to more acidic, short-lived water. Signs of a climate shifting toward the dry, cold world we see today. About 4 billion years ago, Earth and Mars were both volatile young worlds. But Earth's size and warmth allowed it to hold onto a thick atmosphere and long-lived seas. Mars, smaller and with weaker gravity, likely began with rivers, lakes, and perhaps a shallow northern ocean, but its window of habitability was shorter. Even so, that time could have been enough for microbes to arise. The chemistry was there: water, sunlight, volcanic heat, and minerals. Whether Mars water was seasonal or persistent remains debated. Some believe it appeared during warmer intervals. Others think a dense early atmosphere kept lakes and rivers flowing for millions of years. Even after the surface dried, some water likely retreated underground or froze at the poles. Radar hints at possible subglacial lakes, though their existence is uncertain. What's remarkable is how well these features have been preserved. Without tectonic activity, Mars has kept ancient riverbeds, deltas, and lake basins almost unchanged. Their patterns as clear as the day the water vanished. Beautiful, but haunting in their emptiness. One of the most intriguing possibilities lies in the planet's far north. The northern plains form a vast basin, thousands of kilometers wide and much lower than the southern highlands. This depression, along with possible shoreline-like ridges, suggests it may once have held an ocean covering a third of the planet. Fed by rivers from the south, it could have lasted millions of years, perhaps dotted with icebergs beneath a pale sky. Over time, as Mars cooled and lost its magnetic shield, the solar winds stripped its atmosphere. With falling pressure and temperature, water froze, seeped underground, or escaped into space. NASA's MAVEN mission confirms atmospheric loss continues today, though slowly. Isotope ratios in the atmosphere match the story of a vanished sea. Some scientists think this ocean may have formed and disappeared multiple times, tied to volcanic bursts or changes in the planet's tilt. If it existed, it could have been a cradle for life, a place rich in nutrients and energy. Now standing on its former shore, there is only silence, wind, and the ghost outlines of waves that once were. If you stand on parts of Mars today, you can trace faint outlines where an ocean once touched the land. The waves are gone, the sound never comes, yet the shapes remain. On Earth, ancient seas leave shells and coral. On Mars, the hunt is for minerals shaped by long-lost salty water or rock patterns etched by tides. Piece by piece, rovers and orbiters are sketching the portrait of a vanished sea. Billions of years ago, Mars may have been a blue and red world, a northern ocean glittering under a sky thick enough to hold warmth. But that atmosphere, once a protective blanket, thinned until it was less than 1% of Earth's. The air slipped away to space. Stolen by the solar wind after Mars' molten core cooled and its magnetic shield collapsed. Without that shield, light gases like hydrogen fled first. Then carbon dioxide and water vapor followed. Temperatures fell, rivers froze, and only dry channels and empty basins remained. NASA's MAVEN mission shows that even today, tiny bits of air still escape into space, the last whispers of a process that reshaped the planet. Under Mars' thin sky, sunlight feels muted, filtered through a haze of red dust. The sun looks smaller than from Earth, and the wind, though it can reach 100 kilometers per hour, would barely press against your skin. By day, the horizon glows a soft tan. At sunset, the sky pulls a rare trick, fading to blue instead of red. Nights fall hard and fast, with bitter cold that seeps into the ground. This fragile air isn't just thin, it's dusty. Mars is wrapped in a planet-wide layer of fine iron-rich powder that gives it its famous rust color. Over eons, wind ground rock into talcum-sized grains, which oxidized into iron oxide. The dust can linger in the air like smoke, blurring the landscape into soft ochres and butterscotch skies. Sometimes the dust dances in kilometer-high whirlwinds. Other times, it swallows the planet in storms so vast they block sunlight for months. In 2018, such a storm ended NASA's Opportunity rover mission after 15 years. Solar panels starved of light, dust shapes more than weather. It challenges every mission, grinds into machinery, clings to lenses, and will one day coat astronaut suits. But it also tells Mars' story, carrying tiny fragments from across the planet, mixed and remixed by wind over billions of years. Each grain is a piece of history, the ghost of a warmer, wetter world, now locked beneath a silent red sky. Mars is more than red rocks and thin air. It's a world where even the smallest dust grain can hold secrets billions of years old. That dust might carry chemical traces of a time when Mars could have supported life. If microbes ever lived there, their fingerprints could be locked inside those fine particles. Waiting for the right instruments to uncover them, the same dust shapes the Martian sky, fuels planet-wide storms, and blankets the surface in a slow, constant reshaping. Every rover track, every whisper of wind continues a cycle that began when the first Martian stones crumbled. On this planet, dust isn't just part of the scenery. It is the scenery, endlessly shifting, endlessly patient. And rising above it all is Olympus Mons, a volcano so huge it makes Mount Everest look small. Standing 22 kilometers high and wide enough to cover France, its slopes are so gentle that you could walk for days and barely notice the incline. Built by countless lava flows over millions of years, it grew without interruption thanks to Mars' still crust, unlike Earth's shifting plates that move volcanoes off their hotspots. This isn't the only giant here. The Tharsis region holds other titans, each vast enough to be a wonder on Earth, but overshadowed by their massive neighbor. Long ago, these volcanoes belched lava, gas, and heat, possibly melting ice and creating pockets where life might have found shelter. Now, they stand silent, monuments to a planet that once burned with energy, but now rests in cold stillness. To the east lies Valles Marineris, a canyon system stretching for 1,000 kilometers. Nearly 10 times the length of the Grand Canyon. In places, it's 200 kilometers wide and 7 kilometers deep. Scientists believe it began as a colossal crack in the crust, widened over time by landslides, erosion, and bursts of water or lava. Its exposed walls are a geological time capsule, layers of volcanic ash, river sediments, and wind-shaped deposits, telling the story of Mars across eons. Down on the canyon floor, the air is denser, the winds gentler, a rare refuge from the planet's harshness. Landslides here freeze mid-fall, preserved by low gravity, and sunlight crawls slowly down the cliffs at dawn, painting them gold. For future explorers, Valles Marineris could be both challenge and opportunity, a natural fortress, a treasure trove of rock history, and maybe even home to hidden caves that offer shelter from radiation. On Mars, even silence tells a story written in dust, stone, and landscapes too vast to take in at once. Valles Marineris may be the best place on Mars to search for traces of ancient life, if it ever existed. Yet its sheer beauty rivals its scientific value. From orbit, the canyon's scale is almost absurd, a reminder that planetary forces shape landscapes far beyond human experience. On the ground, shifting light and shadow play across endless cliffs, slopes, and colors, while dust devils roam its floor. If the Grand Canyon can make you feel small, Valles Marineris can make you feel microscopic. To journey through it, in a rover, a spacecraft, or imagination, is to read the planet's story on walls carved by forces we still struggle to understand. It's a scar, a rift, a monument, and perhaps a refuge. At Mars' poles, vast caps of ice and dust crown the planet, their spiraling patterns stark against the red terrain. Their layered archives of climate history, recording changes in tilt and weather over millions of years. The north cap is larger, sculpted by wind into graceful troughs. The south is thicker, with carbon dioxide ice locked in place for millennia. Unlike Earth's poles, Mars changed dramatically with the seasons. In winter, carbon dioxide from the atmosphere freezes into a meter-thick layer of dry ice. In summer, it sublimates back into gas, shifting the planet's air pressure. This breathing cycle can even trigger geyser-like eruptions of gas and dust, leaving dark wind-shaped stains on the ice. Beneath these seasonal layers lies enough water ice to flood Mars in a global ocean over 10 meters deep, a vital resource for future explorers. From the surface, the poles are silent, bitterly cold deserts of white and dust, changing from shimmering frost to rust-colored dunes as the seasons turn. In summer, the sun circles without setting, etching ripples, pits, and spirals into the ice. Every layer underfoot is a frozen page in the planet's history, written over eons. Above this world drift Phobos and Deimos, two tiny misshapen moons, more like captured asteroids than miniature worlds. Deimos, small and distant, crosses the sky like a bright star. Phobos, larger and much closer, races from west to east in just over 7 hours, visible several times a day. Their origins remain uncertain, perhaps captured from the asteroid belt or born from debris after a massive impact. Deimos drifts slowly away from Mars. Phobos spirals inward, inching 2 meters closer each century. In 30 to 50 million years, it will either crash into Mars or break apart into a temporary ring. Long grooves and fractures already mark its surface, signs of the strain pulling it toward that fate. One day these moons could serve as way stations or observation posts, offering views of Mars so breathtaking they de-rival any scene from space. The planet's deserts. Volcanoes and canyons spread beneath a sky far from Earth's blue. From the surface of Mars, Phobos is the real showstopper. In daylight, it can zip across the sun, throwing a quick-moving shadow that races over the landscape. These partial eclipses last barely half a minute, dimming the already pale sunlight in a blink. Deimos, on the other hand, is more subtle. Its tiny shape barely winks against the sky. At night, both moons bring a different beauty. Deimos drifts slowly like a bead of light, while Phobos speeds from horizon to horizon in just a few hours. They orbit in opposite fates. Phobos slowly falling toward Mars, destined to shatter or burn, and Deimos inching outward toward freedom. For now, they continue their timeless dance, silent companions circling a lonely world. When people picture Mars, red is the first word that comes to mind, a deep, rusty color seen from space. That hue comes from an ultra-thin coating of iron-rich dust, formed over billions of years as wind and temperature changes broke down rocks, letting the iron oxidize into rust. Up close, the planet's colors are far more varied. Dark volcanic plains, pale dust-blown deserts, streaks of ice, yellowish sulfates, and even bluish or greenish minerals in certain light. Seasonal dust storms can blanket the entire world in a soft orange haze, changing the landscape's tones as the winds shift. The Martian sky is usually a warm butterscotch color, due to dust scattering sunlight differently than Earth's atmosphere. But at sunset, the horizon glows orange, while the area near the sun turns a delicate blue for just a few minutes. The reverse of Earth's sunsets. Mars is more than just a visual experience. In 2021, NASA's Perseverance rover let us hear it for the first time. The planet is astonishingly quiet. No background hum of life or rushing air. When the wind blows, it's a soft hiss, more intimate than cinematic. Rover wheels crunch faintly over gravel, and its instruments give off small clicks and creaks. Sound here travels slower and fades quickly because of the thin, CO-heavy atmosphere which dampens high tones and makes voices sound deeper. Occasionally, Perseverance records dust devils passing by, grains striking its body like dry rain, or the faint static pop of its laser vaporizing rock. On Mars, every sound is isolated and unhurried, allowed space in the silence. Now, we don't just see the red planet, we can hear it, and in that quiet, it feels even more alien. Mars holds a silence unlike anywhere else, not emptiness, but patience, as if waiting for its next chapter. For centuries, we've wondered if that chapter might include life. Not forests or animals, but hidden microbes, clinging to survival in unlikely places. In 1976, NASA's Viking landers became the first to touch down and search directly for life. Their experiments didn't look for creatures, but for the chemical signatures of living processes. One test suggested something in the soil was breathing, but others disagreed. Most scientists concluded it was unusual chemistry, not biology, yet the debate never fully ended. Since then, our focus has shifted from, is it alive? To, could it ever have been? We've searched for evidence of ancient water, organic molecules, and habitable environments. One clue that keeps resurfacing is methane. On Earth, microbes produce much of it, though geology can as well. Methane doesn't last long in Mars' atmosphere, so detecting it means something. Alive or not, is actively producing it. Both orbiters and rovers have detected plumes, sometimes with seasonal patterns, but the source remains mysterious. Mars makes preserving life's traces difficult. Harsh radiation and chemical reactions on the surface quickly destroy organics. The best chance may lie underground, where life could be shielded. Perhaps surviving in briny pockets warmed by the planet's interior. Rovers like Perseverance are now collecting ancient lakebed samples, hoping future Earth-based analysis might reveal microscopic fossils. But extraordinary claims demand extraordinary proof, and the Viking experience has made scientists cautious. If life ever existed here, it may have vanished without a trace, never emerged at all, or still be hiding deep below. Mars gives us just enough reason to hope, with evidence of water, chemistry, and energy, yet keeps the final answer locked away. Long before technology made it possible, people dreamed of walking on Mars. Early visions painted domed cities under dusty skies, canals, and alien landscapes. As knowledge grew, science fiction began blending with real engineering. By the mid-20th century, scientists were sketching missions, some imagining vast spacecraft carrying settlers. Today, plans are more concrete, but the challenges are formidable. Intense radiation due to the lack of a magnetic field, toxic and clingy dust that can damage machinery and harm. Lungs isolation with long communication delays, and the unknown effects of Mars' low gravity on the human body. Despite the risks, the pull of the red planet endures. Whether for science, survival, or sheer human ambition, Mars remains our next great frontier, one that could redefine our place in the universe. Imagine stepping onto Mars for the very first time. The sky is tinted butterscotch, the sun a pale disk, the air so thin it can't be breathed. Through your helmet, there's a stillness deeper than any you've known. Each light step sends rust-colored dust, drifting lazily in the weak gravity. And planes stretch farther than they seem, the cold biting through even the best insulation. Your life depends entirely on the technology wrapped around you. Inside your habitat, the air feels Earth-like, but just beyond the walls, it's a frozen desert, averaging -60 degrees Celsius. Oxygen systems hum. Water is recycled from ice, or drawn from the atmosphere, and every drop is precious. Soon, work begins. Instruments deploy, solar panels unfurl, and perhaps a small greenhouse starts the first Martian crop. This is not just science. It's humanity testing its grip on a new world. Night drops fast. Stars blaze in razor-sharp clarity as Mars' tiny moons drift overhead. You think of the millions of kilometers between here and home, and the fragile bubble keeping you alive. Humanity is here, proving our story can grow beyond one planet. Long before this day, machines paved the way. From the brief flybys of the 60s to Mariner 9's game-changing orbit in 1971, we learned Mars was far more than a dead moon-like sphere. It had volcanoes, canyons, and riverbeds. Viking landers touched down in 1976, proving long-term surface operations were possible. Even as their life detection results stirred decades of debate, rovers soon followed. The small Sojourner tested our first wheels on alien ground in 1997. Spirit and Opportunity arrived in 2004, meant for 90 days, but lasting years. Spirit explored for 6, before getting stuck. Opportunity roamed nearly 15, sending home stunning vistas, until a global dust storm ended its watch. Curiosity, landing in 2012, still climbs Mount Sharp, uncovering Mars' watery past. Perseverance arrived in 2021, drilling rock for a future sample return. With the tiny helicopter Ingenuity flying dozens of missions, the first aircraft on another planet. Above it all, orbiters map, monitor, and scout, revealing Mars in detail no telescope could match. Mars weather would make any forecast sound ominous. Daytime near the equator in summer might reach 20 degrees Celsius, but nights plunge below minus 70 degrees Celsius. Thin air means winds feel gentle, yet dust they carry can infiltrate every crevice. Towering dust devils roam the plains, and seasons stretch twice as long as Earth's. Global dust storms can dim the sun for months, threatening solar power, while calmer days bring blue-tinged sunsets fading to pink. One day, human footprints will join rover tracks in the Martian dust. And when they do, it will be because of the quiet pathfinders, machines and missions, that first open the way. On Earth, sunsets glow, warm and red. Mars does the opposite. Fine dust scatters sunlight so the sun's center turns bluish, haloed by pale gold. It's a surreal sight, as if the planet itself is whispering that it follows different rules. Days on Mars, or Sol's, last just over 24 hours, but the similarity ends there. Thin air can't hold heat, dust hangs in the skies, and long seasons bring swings from calm to fierce. Standing under that muted horizon, you feel that Mars weather is less about comfort and more about quiet survival. This alien harshness is why some dream of terraforming, reshaping Mars into a place where humans could breathe without suits. The vision starts with the atmosphere, barely 1% of Earth's pressure and mostly carbon dioxide. One idea is to trigger warming with greenhouse gases, melting frozen CO and water to create a thicker, warmer atmosphere. Science fiction has pictured giant mirrors and machines turning red plains green in decades. Reality is tougher. Even using all available CO might not make it breathable. And without a magnetic field, any new air would slowly leak into space. Instead, smaller-scale terraforming could build vast domes or underground cities with controlled climates. It's less grand, but more achievable. Yet there's an ethical dilemma. Changing Mars could erase any native life, even microscopic, and destroy its untouched history. Some see protection as a duty. Others see transformation as humanity's survival plan. Even the rosest timelines stretch over centuries, and by then, our technology and values might shift so much that we choose to adapt to Mars rather than change it. Long before rovers, Mars existed as a symbol. Its red hue linked it to blood and war in cultures worldwide, from the Roman god Mars, protector of armies, to Babylon's Nergal and Hinduism's Mongola. In the 19th century, telescopes revealed polar caps and dark streaks. A mistranslation of canal into canals sparked tales of an intelligent civilization. Taya Wells imagined Martian invasions, while pulp fiction filled the planet with deserts, tribes, and adventure. Mars-inspired panic with Orson Welles' 1938 radio drama, stirred wonder with Edgar Rice Burroughs' Barsoom stories, and brought nostalgia in Ray Bradbury's Martian Chronicles. Observatories drew crowds, newspapers blurred fact and fantasy, and composers and artists used its landscapes as symbols of both menace and beauty. Over time, Mars became less a real place in the sky and more a mirror, reflecting our fears, ambitions, and longing for worlds beyond Earth. Today, robotic explorers have stripped away much of Mars' old myths, yet it still captures our imagination. We no longer speak of certain canals or invading fleets, but the red planet remains a stage for human dreams. In the next century, it will shift from a distant spark in the night to a place we know well, not because Mars will change, but because we'll be there. Space agencies and private ventures are mapping paths once reserved for science fiction. Robotic supply lines, sample returns, and perhaps human footprints in the dust within decades. History warns us that bold timelines often slip, so the first era of this new chapter will likely belong to machines. Future rovers may travel farther, dig deeper, and return Mars' first rock samples to Earth, a step that could reshape what we know of its history and habitability. Human landings will be the harder leap. Mars' thin air makes slowing heavy craft tricky, too dense to ignore, too light for parachutes alone. A crewed round trip could take 3 years, with long months of confinement, radiation exposure, and no quick rescue. Surviving on Mars will mean making air from carbon dioxide, water from ice or vapor, and food in controlled greenhouses, each possible, but altogether a daunting challenge. Some dream of domed cities or lava tube colonies, lit by artificial suns, turning Mars into a second home. Others argue it should remain like Antarctica, visited, studied, but largely untouched to protect its environment and any life it might hold. We may see a mix: permanent robotic bases, rare human visits, and a slow weaving of Mars into humanity's sphere without fully remaking it. Whatever path unfolds, Mars will no longer be just a curiosity. It will be a conversation between two worlds. From Mars, Earth is only a pale blue dot, small enough to hide behind your fingertip. At their closest, the two planets are 34 million miles apart. At their farthest, more than 200 million. Even light takes minutes to cross the gap, turning a simple conversation into a ritual of pauses and care. That view erases borders and quarrels. From here, Earth is simply one fragile home. Astronauts call this the overview effect, but from Mars, it's magnified. Our planet looks less like a place and more like a memory that holds every ocean, every song, every person, and from here, it feels impossibly far. Mars' barren silence deepens the effect. It isn't the quiet of a winter morning. It's a stillness that belongs to a world alone under a thin sun. For those who might live there, Earth's glow could become a daily ritual, a reminder of why they came or what waits far away. Over time, home might stop meaning one planet and instead become the bond between them. Earth, the cradle. Mars, the frontier, both chapters in the same human story. On Mars, distance reshapes the very idea of conversation. Messages crawl across millions of miles, turning quick exchanges into patient, deliberate notes, more like letters than dialogue. The moon offers the comfort of seeing Earth looming in the sky, bright and steady. But for Mars, our home is just a faint glimmer among the stars, visible only if you know where to look, fragile enough to vanish behind a blink. That view carries weight. Humans evolved, surrounded by constant sights, sounds, and voices. Mars strips that away. Beyond your crew, the planet feels indifferent, vast plains stretching to the horizon. With no plants, no birds, not even the hum of insects. Its silence is almost physical, pressing in like a soft blanket. In that stillness, every sound you make stands out. The crunch of boots on dusty ground, the hiss of your air supply, the faint sigh of thin winds that have crossed the same stones for eons. Some would find it oppressive, others peaceful. Mars moves at its own slow rhythm, shaped by seasons twice as long as ours. The stillness is ancient, unchanged by your presence, like stepping into a room sealed for ages. Over time, such isolation can wear on the mind, so explorers will need to create their own patterns and noise to anchor themselves. Yet for some, the absence of life's constant background hum might be a gift, a rare space for reflection beneath a pale salmon sky. Mars' silence is not emptiness, but endurance. It reminds us that life is rare, not the universe's default. And within that quiet lies beauty, in the way frost settles on dunes under alien stars. In sunsets that paint the sky blue over a red horizon, and its patient moons circling overhead, science dissects the planet's details, measuring the thin air, reading rock chemistry with lasers, mapping every slope and crater. We know its red dust comes from iron oxide, that volcanoes once swelled slowly over millions of years, and canyons tore open under ancient tectonic strain. But mystery persists. Was Mars once warm and blue, with rivers and seas? Did life arise and fade, or does it still linger in hidden pockets underground? Even the methane detected at times refuses a clear explanation. Beyond the data, Mars stirs something deeper. Its dried riverbeds mirror our own landscapes. Its lost atmosphere warns how fragile habitability can be. Every image it sends back is part of a shared human story, one of curiosity, resilience, and the urge to cross the next horizon. Someday, people may stand there watching Earth as a tiny spark in the dark, carrying the history of every mission before them. Mars will remain a place where science, mystery, and poetry meet. A planet that neither rushes nor waits, but turns on its own terms, holding its secrets until we're ready to uncover them. Mars is a vast, open record of planetary history. Each valley, crater, and dune, a chapter in a story written over billions of years. Some are carved by ancient rivers, others by violent impacts, and still more by the slow escape of air into space. If Earth is a vivid novel still unfolding, Mars is the weathered volume beside it, its pages faded and torn, showing what happens when a planet loses its warmth and protective shield. It's not just Mars' story, it's a cautionary tale for us. It shows how fragile the balance is that keeps seas liquid and skies breathable. For billion years ago, Mars may have been warmer and wetter, with lakes and streams under a blue sky. Over time, water vanished, the atmosphere thinned, the magnetic field went silent. If life began, it either retreated deep underground or disappeared. Mars teaches patience. Its changes unfold on timescales beyond any human plan. Continents shift, ice caps grow and shrink, dunes drift grain by grain. Our struggles and triumphs are mere flickers compared to that slow march, yet beauty remains. Polar frost, breathing with the seasons. Mountains etched against a pale sky, wind-shaped sands rippling for millennia. There's humility in its resistance. We dream of greening its plains, filling its lakes, and warming its skies. But Mars reminds us that worlds are not easily remade. Sometimes the value lies in listening, not changing. And in listening, we've found perspective. From Mars, Earth is just a faint blue spark, a reminder of our shared home, small and fragile in the dark. Mars is also the keeper of quiet, a silence deeper than anything on Earth. No leaves rustling, no waves breaking, only the thin sigh of wind over rock. It asks us to slow down, to notice the smallest details. A curve of an old riverbank, layers in a cliff, frost etching stone at dawn. It shows that endurance can be as powerful as abundance. Perhaps that is why it holds our imagination. It is both a destination and a mirror. One day, we may walk its deserts, leave footprints in its dust, and watch its moon skim the sky. Till then, Mars turns patiently beneath the sun, holding its secrets, while Earth glows as a distant light beyond its red horizon.